Alright, in this video we're going to be solving this word problem using what we know about inverse variation so far. So it says the inverse variation, x times y equals 2,400, relates to the vibration of the frequency y in hertz to the length x in centimeters of a guitar string. Determine a reasonable domain and range and then graph its inverse variation. Use the graph to estimate the frequency of vibration when the string length is 100 centimeters. So first we're going to have to solve our function for y, so that way we get our equation that we can graph. So we have xy equals 2,400, and we're going to solve for y, so that means y equals 2,400 divided by x. Now we're going to decide on a domain and range. Well, we know that a guitar string length, the length is never going to be less than 0. We know it's always going to be a positive value, so x is going to be greater than 0. Since our x is going to be positive, and we already know that x times y is also positive, we therefore know that y is also going to be a positive value. So now if we go down here to step 3, we're going to use the values of the domain to generate, see if we can get there again. Use the values of the domain to generate reasonable ordered pairs. So we know we wanted positive values. If I peek down at my graph, I kind of see where I'm going to be graphing on. So I'm going to pick 20 as our first x value. So when we put that into our equation of y equals 2,400 over x, we get that y is equal to 120. Next, I'm going to choose the value of 40. And when we put that into our equation, we get that y equals 60. I'm then going to choose 60 as our length of guitar string in centimeters. When we put that into our equation, we get 40 hertz. Lastly, I'm going to choose 120. And when we divide 2,400 divided by 120, we get 20. So now we're going to use these ordered pairs and to create our graph. So we're going to put them on this graph, if I can ever get there. Okay. So we're going to plot these points. So first we had 20, 120. So over 20, up 120. Then we had 40, 60. We had 60, 40. And 120, 20. So now we're going to connect it. So our curve is going to look something like this. Okay. So now if you look at step 5, it's asking you to find the y value where x equals 100. So we can first kind of give us an estimate on our graph. So if we look at our graph, we can go over to 100. We're going to go up until we hit our curve. And then we're going to go over to see what that value might be. I know this is 30 here in between the 20 and the 40. That means this is 25. So I'd say it's roughly 24 hertz. So now let's check that numerically. See if we get that same value. So if we go down here to step 5, so let's use the graph to estimate the frequency of the vibration when the string length is 100 centimeters. So when we use the graph, we said that was about 24 hertz. And we can also check that too. So we have y equals 2,400. We said our x value is 100. When we solve that, we get y equals 24 hertz. So that checks out.